Dear viewers, my name is Muhammad and welcome to this video. In this video, I will be discussing the current percentage display function on Multimeter. I will explain how this function works and provide a comparison between the two common current measurement range of 0 to 20 mA and 4 to 20 mA. Additionally, I will demonstrate how to calculate current percentage. The current percentage is a feature found in many multimeters that allows you to calculate the percentage of current flowing through a circuit related to the 20 mA. There are two common current measurement ranges, 0 to 20 mA and 4 to 20 mA. This feature is useful for a variety of applications, including troubleshooting and monitoring electrical systems. To calculate the current percentage in the 0 to 20 mA range, you need to divide the measured current by 20 mA and then multiply the result by 100. This will give you the current percentage. For example, if the measured current is 10 mA, the current percentage will be 50% because 10 mA is half of 20 mA. In the 4 to 20 mA range, you first subtract the minimum current value of 4 mA from the measured current and then divide the result by 16 mA, which is the difference between 20 mA and 4 mA. Finally, multiply the result by 100 to get the current percentage. For example, if the measured current is 12 mA, the current percentage will be 50% because 12 minus 4 divided by 16 multiplied by 100 equals 50%. Let me give you a few other examples. If the measured current is 4 mA in the 4 to 20 mA range, you can plug it into the formula and see that the current percentage is 0% because 4 mA minus 4 mA equals 0 mA and 0 mA divided by 16 mA is 0. However, the measured current percentage is 20% in the 0 to 20 mA range. If the measured current is 12 mA in the 0 to 20 mA range, you can calculate the current percentage by dividing 12 mA by 20 mA, which equals 0.6, then multiply by 100 to get 60%. But as we discussed earlier, 12 mA in the 4 to 20 mA range is equivalent to 50%. If your multimeter displays a current percentage of 25%, you can use this information to determine the measured current. In the 0 to 20 mA range, the measured current will be 5 mA, because 25% of 20 mA is 5 mA. And in the 4 to 20 mA range, the measured current will be 8 mA, because the difference between 20 mA and 4 mA is 16 mA. And 25% of 16 mA is 4 mA. So the measured current is 4 mA plus 4 mA, which equals 8 mA. The two common current measurement range are 0 to 20 mA and 4 to 20 mA. The main difference between these ranges is the minimum current value that can be measured. In the 0 to 20 mA range, the minimum current value is 0 mA, while in the 4 to 20 mA range, the minimum current value is 4 mA. This makes the 4 to 20 mA range more suitable for applications where 0 mA current reading is not expected. The choice between the 0 to 20 mA and the 4 to 20 mA ranges depends on the specific application. If you expect to measure current close to 0 mA, then the 0 to 20 mA range may be more appropriate. However, if you are working with sensors or other devices that output a minimum current value of 4 mA, then the 4 to 20 mA range would be the better choice. The 4 to 20 mA range is more commonly used in industrial applications, especially with sensors and transmitters. This is because many sensors and transmitters have a minimum output of 4 mA when there is no measurement signal being detected. This minimum current value is sometimes referred to as the offset or bias current. In the 4 to 20 mA range, the 4 mA current value can be used to indicate that there is no measurement signal, while the 20 mA current value can indicate that the maximum measurement signal has been detected. In summary, the current percentage function on multimeters is a useful feature that allows you to calculate the percentage of current flowing through a circuit relative to the 20 mA. The choice between the 0 to 20 mA and 4 to 20 mA ranges depends on the specific application, with the 4 to 20 mA range generally being more suitable for industrial applications involving sensors and transmitters. Calculating current percentage is relatively straightforward, and understanding how to use this feature can be beneficial in troubleshooting and monitoring electrical systems.